Hello, my name is Miss Jones. I teach elementary school math, and welcome to my channel, Miss Math Jones. Today, we're going to be working on our third grade Eureka Module 5, Lesson 21 homework. The objective for our homework is to recognize and show that equivalent fractions have the same size, though not necessarily the same shape. Let's get started. Number 1 says to label the shaded fraction and draw two different representations of the same fractional amount. So we're just labeling what fraction the model shows, and then we're going to draw two different ways to represent the same fraction. So let's get started. Now, for number 1, how many pieces are shaded? Well, if you said 3, you're absolutely correct. Now, that's going to be our numerator. So 3 is going to be our top number, or our numerator. And how many total pieces do we have? If you said 7, you're absolutely correct. So our denominator, or our bottom number, is going to be 7. So the entire fraction is 3/7. Now we have to draw two more models that show 3/7, but we have to draw them in different ways. Now, your models don't necessarily have to look like mine, okay? But this is what I'm going to do for my first model. So I'm going to draw one here, and that's one shaded in, and okay, not shaded in the second one. Put that one there. Okay, that's 3. It's 4. I need 7 total. 5. Draw one here. 6. And one more. 7. So I have 7 total squares, and I've shaded in 3. So this model, although it looks different from the other one, the squares are about the same size, and I'm showing the same amount. So this model is also 3/7. Now, I need another model. So I need 7 total squares, but these need to be arranged differently because it said two different representations of the same fractional amount. So let's see. Focusing on 7 here. So let's see. 1, 2, 3, 4, 5, 6, 7. Now, I made this one look like the letter T, right? And as you can see, my squares are about the same size as the original model. Now, I don't expect it to be perfect because it's hard to make squares that are the exact same size. And I made sure to only shade 3 out of the total of 7. So this model is also 3/7. Now, if you want to pause your video to try to make your models look like mine, then you're more than welcome to do so. If you want to make models that are different from mine, as long as they show 3/7, that's okay also. All right, let's take a look at number 2. Number 2 says these two shapes both show 4/5. Okay. 4/5 in little squares and 4/5 in long rectangles. Are the shapes equivalent? Why or why not? That's what A says. Are the shapes equivalent? Why or why not? Well, in order for them to be equivalent, you have to be comparing something that's the same, right? So although they represent 4/5, both of them, they're not the same size. So the answer to this question is no. The shaded areas are not equivalent. Both shapes have 4 shaded shapes, but the size of the squares or rectangles in each shape is different. That means that the shaded areas can't be equivalent. Now, if you need to pause your video to write the explanation that I have on my screen, go ahead and do so now. All right. Letter B says draw two different representations of 4/5 that are equivalent. So we need to draw two different shapes. Both of them need to represent 4/5, and the objects that we use need to be about the same size. So my models are going to look like this. This is my first one. I need 5, and 4 of them have to be shaded. So my first one's pretty basic. right? So I have 1, 2, 3, 4, 5 squares, and 4 of them are shaded. And here's my second one. Didn't get too fancy. But still 5 squares, and 4 of them are shaded. So it's still 4/5. And I just made sure that I used about the same size squares for both to make sure that they were equivalent or equal. Now, if you need to pause your video to create models that look like mine, go ahead and do so. If your models don't look like mine, as long as they're the same size, the units, each square that you use, doesn't matter how they're arranged, as long as they're the same size and they create one shape, right? And you have 4/5 shaded, then that makes them equivalent or equal. Now we're moving on to number 3. Number 3 says Diana ran a 1/4 mile straight down the street. So she ran a 1/4 of a mile, 1/4 of a mile. A quarter is 1/4 because 4 quarters are in a dollar. So that's 1/4. Okay. So she ran a 1/4 mile straight down the street. Becky ran a 1/4 mile on a track. So Becky also ran a 1/4 mile, but she ran hers on the track, round and round in a circle. Who ran more? Well, who do you think ran more? Was there any difference in the amount they ran? There's a difference in the direction they ran. Like one ran straight, the other ran around a track, but they both ran a 1/4 mile. So who ran more? Well, if you said they both ran the same amount because the units are the same, then you're absolutely correct. Diana ran a 1/4 mile, Becky ran a 1/4 mile. They ran on different surfaces. One ran down the street, the other ran down a track, but guess what? It was both a 1/4 of a mile. So they both ran a 1/4 of a mile, even though they ran in different ways. Diana ran in a straight line, and Becky ran in a circular shape. The shapes look different, but they are both the same distance, 1/4 mile or 1/4 mile. Now, if you need to pause your video to make sure that your explanation looks like mine, go ahead and do so now. Congratulations! Lesson 21 homework is complete. As always, I hope this video has helped you to complete your homework correctly, and I hope this video has helped you to understand Lesson 21 a little bit more. And as always, make sure that when you're completing math to check your work, just to make sure your math is mathing. This is Miss Jones saying bye until next time.